Hello everybody. Today we're going to be looking at parallelograms, which is a huge umbrella term for quite a lot of our special shapes. They start off as parallelograms because parallelograms have a lot of characteristics, and so we just refine those a little bit more, and that's when we get a lot of our special shapes of rectangles and rhombuses and squares and stuff we're going to build up to. So what is a parallelogram? A parallelogram is a quadrilateral, so still sticking with four sides, with two pairs, so two pairs would be four, so all of them, two pairs of parallel sides. So every side is going to be parallel to the one opposite. Obviously, it's not going to be parallel to the one next to it because they would run into each other at the corner or the vertex. So they're going to be parallel to the sides opposite of them. So what could these look like, and what do they really tell you? And the answer is a lot. Okay. So what we know, if we know something is a parallelogram, we know that this side is congruent to this one, and this one is congruent to that one, which seems, okay, great, that's fine, doesn't matter. But there's a lot of implications here. So that is one thing you know. Great. You also know some very interesting things about the side lengths. Okay, that one's not very parallel, but you get the idea. I know that my opposite sides are going to be congruent. So if I know that, that's a parallelogram as well. Or, okay, I know my opposite angles could be congruent. That tells me it's a parallelogram. Or, I know, there's a lot of stuff going on here. Say I have this, and we go back to those diagonals that we talked about with kites. I think was the last main time we talked about those. Let's draw those diagonals where they cut across. Okay. Now these are not necessarily perpendicular like they might be if they were, or they would have to be, I guess, if they're in a kite. But I do know that they bisect each other. So I know this. Or, last main one we're going to get to. If I have this one, I actually may not know anything about two of the sides, but if I know one of the pairs is parallel and congruent, so they're both 3 inches and they're parallel or something like that, that's actually enough because there's no real way to make these be something other than parallel because they're a set distance, right? And since I have endpoints, I can't like flip this out this way and turn it into a trapezoid because this one's not long enough to reach anymore. So there's a lot of characteristics with parallelograms that are very, very important because if I know any one of these, all of them are true. I know that the opposite sides are congruent from this if I know they're parallel. I know the angles are congruent if I know they're parallel. That's kind of a combination of those two. I know their diagonals bisect each other if they're parallel. And vice versa. If I know their diagonals are, if I know their diagonals bisect each other, I know they're all parallel and congruent, and the angles are congruent. All of these tie into each other because if you know any one of them, you know all the rest of them. So there's a lot of interesting things with parallelograms that we get from relatively little information. Each of these is like 2 separate pieces, so paracongruent, or paraparallel, paraparallel, paracongruent, paracongruence, pair of congruent angles, 2 congruent segments again. And I know a lot of information from parallelograms. Okay. Now, why does that really matter? What can we actually do with this sort of thing? Okay. So let's try out an actual application where I use some of this information. Okay. So let's say I have let's rotate this so we don't think they're all the same every single time. Let's take one that looks like this. That does not look very parallel, but you get the idea. So I'm telling you it is parallel, so I have that. So I know this is B, C, A, D6. We'll cut across here so we can talk about the diagonals. And oh, and we know this is a parallelogram. I will tell you that ahead of time. Okay. So, and I know this is 64, this is 67, and 2x. Okay. So what I want to do is I want to find this x, obviously. I also want to see if I can figure out this one, which so I'll call that y. And I want to know if I can find this one. So we'll call that z. Those are the three things I want to try and find. Okay. Knowing this is a parallelogram, if I didn't know that, I would be completely stuck. But I do, so I can do some sneaky information. So let's go ahead and do x first. We'll do the sides because the sides and angles are fairly separate, but we'll go ahead and do the sides first. So looking at my picture up here, it tells me that opposite sides have to be congruent. So if I know this is 6, this one has to also be 6 because they're on opposite sides of our big parallelogram. So to find x, I'm just going to say, well, those have to be equal because they're congruent, and solve for x. So I just find out that x is 3. Oops, sorry. And I'm done. How do I find y and z? Well, for that one, I need to go back to some of my angle stuff, specifically right here for the first part. So I know opposite angles are congruent as well. So if this is 67, coming up here, z has to be 67 as well because they're opposites. Okay. All right, that's great. How do we do y? I don't know anything about the one opposite of y. That's true. But we know a lot about parallel lines. So if these are parallel, and I look at this as my transversal, these are interior, same side interior angles. If I look at this whole thing together as opposed to just y. So this, which is y plus 64, plus this one, have to equal 180 degrees because they're supplementary. So knowing that, I now have enough information to find y. So let's simplify this up. 64 and 67 is 120 and 11, so plus 131. Subtract that 131. And we end up with 49 degrees. Okay. So I can use these different relationships to find a bunch of information in here. So that's how we use some of that stuff if we know something's a parallelogram. So try those out. There's a lot of things they could do, so see what you can do. This, especially when we get a little more into some of this stuff, it's more like a puzzle than it is a normal math problem, which is really where geometry thrives. So try it out, see how you do. If you get stuck, let me know, but do your best. See how you go.